My name is Jim Shute. I am the Cloud Computing and Data Services Lead here at NCCS. This presentation is about the GIS portal that we have here at NCCS, the capabilities and services that we offer, and I'll show you kind of a soup to nuts approach on how you can get your analysis data published to the web. So this is kind of what we're going to go over. We'll talk a little bit about the NCCS architecture and then what our spatial platforms look like, what I'm calling the GIS development paradigm. Show you an example workflow from someone who's already using the system. We'll talk a little bit about how data gets published. There's some additional information about development options, how you get access to Windows, and then we'll do a demonstration and some wrap up. At a high level, this is what the NCCS is. Over on the bottom left, we have our high performance computing on-premises platform, which is Discover. Then you also see that there's a Discover file system there. On the bottom right, we have the on-premises virtualization, which includes Data Portal, where the NASA Disasters GIS and the NCCS GIS reside. There is a separate file system for that. And then over on the far right, we have Adapt. And you'll notice the linkage between the Adapt file system and the Data Portal, which I will explain shortly. We also have the cloud offering at AWS, primarily AWS, which is SMCE, that we have the capability to burst out there for analysis if we need it. This is what our spatial platform architecture looks like. You'll notice that there's one portal, but then we have 6 ArcGIS servers. Each one of these ArcGIS servers has its own function. So for example, ArcGIS Server 3 only supports mapping, and that's primarily of vector data. We have 2 separate image servers. So if you have some raster data you want to visualize, you can use either one or both of those. And then we have one that's dedicated over here on the far right to geoprocessing. So the idea is you come up with an automated workflow, and then you configure a geoprocessing tool that you can call via the REST API if necessary. And then we have shared file systems here on the back end that you can view and do your analysis, both with the ArcGIS servers through geoprocessing or through visualization. So this is the GIS development paradigm. So the main takeaway here is that everything starts with data, right? So whether that be vector data, raster data, we have tons of it here at NCCS. From data, we publish services. Those services then go into web maps, which really don't have a whole lot of functionality. It's just basically a couple of zoom tools and things like that. But then we build apps, which are lightweight, easy to build apps on top of that. And then at the high end, we have applications, which are more custom. This is an example workflow of publishing a time series data set that we did for the landslide susceptibility model over in Bangladesh. Really, the key takeaways on this slide is this first bubble right here in green. What that is the work that the actual scientist did on the Linux side. So he went into the Adapt environment, performed his analysis, and generated products. For this particular effort, he generates some raster data in a series of shapefiles every night at midnight. And these other green bubbles are just kind of setup steps that we had to do. We had to create a mosaic data set for his raster data for both the web applications and ArcGIS desktop. We set the desired window of the time series to 120 days, and then we went ahead and published those services in advance of loading his data. And then our nightly script basically goes through this process where it looks at his directory, finds any new files, brings those over, deletes any old files, and updates the web services accordingly. This is our data publishing workflow. What we're trying to show here is that users will work inside of Adapt, and within Adapt we have our Windows-based environment. They will work either in their working directory, or we have a directory called ArcShare Public, which is down here at the bottom. So the key thing with the ArcShare Public directory, let me just take a step back. If you use the Esri tools in Windows in the NCCS and you're doing it in your no backup or home directory and you try and publish it to a server, it will not work, or it will try and copy the data to the server, which is what you do not want. So what we've done is we've created this ArcShare Public directory that is a shared directory. I will show it in a minute. If you copy your files into that shared directory and then publish, the servers can see that data because we've established this connection here between 3 and 4, where the actual servers, which are all Linux-based, they can actually see that data in a read-only fashion. And then your portal users will get to your data through the proxy servers and through the portal in ArcGIS server. Just one quick note about when you're developing apps for GIS tools. You have to find the balance between capabilities and customization and deployment time and complexity. So what I mean by that is, if you really just want something out there quickly, you can just publish a service, add it to a web map, save the web map, and share that. We do have some users that do that, but there aren't any widgets like calculating values or anything like that. But then as you gain capabilities, the deployment time and the complexity required to get to those capabilities increases. So for example, Esri has a tool called Survey 123. It's pretty straightforward. You can basically get something out there quickly, but the problem is if you want to customize that app, you don't really have much of an option here. All the way up here on the far upper right, we have one customer, the G-Lite project, that actually just uses our ArcGIS servers for their REST services, which are raster-based. And then they actually have built a custom leaflet application that calls those REST services and displays it on her web server. And then, the ultimate is to build your own desktop application. So how to gain access to Windows. So a lot of people are used to the old SSH-XY to launch our desktop. We do not recommend that. We recommend using the Guacamole tool, which is at guac.nccs.nasa.gov. It's much faster. It's Launchpad enabled. You do require an NCCS account to get to that. And if you already have an NCCS account, but you need access to this environment for Windows, then you would need to submit a ticket to support at nccs.nasa.gov so that you can go ahead and get your account added to the Windows platform. This is our home page. We have a couple of applications that are out here. These are actually applications that are sitting on our portal that are publicly available and that we have embedded as widgets into this page or as iframes into this page. So the key here is that whatever I'm about to show you in the app world, you can actually take that URL and embed it as an iframe somewhere else. Here's another map from the Above Airborne campaign that shows all of their flight lines and areas of interest. And these are fully functional apps, right? So I can actually launch the full application if I want to drill down into what's behind the scenes here. If you get some time, I recommend you check out this barn swallow climate story map. We had an intern 2 summers ago who actually put this together. And what it does is it looks for a correlation between surface temperature and barn swallow migration paths. And it's actually pretty cool. She did find a direct correlation, and she has some analysis that shows that. And then finally, at the bottom of the page, this is our popular content. So we have a whole bunch of data that's already preloaded into the system. And then some data that's not displayed here that I will show you shortly. So you can click any of these, and you can see what we have that's from the Above group. The NASA Disasters Program, we list some linkages to them. These are our public data sets. So you'll see we have a coal plant tracker database, a power plant database. We have the Tropical Outlook app that I just mentioned. We have the high field data, and we just have a couple of different tools here that are helpful to give you an idea of not only what data we have on the system, but what you can do with the applications themselves. One of the success stories of the NCCS GIS is the Global Landslide Catalog. So I'm not going to drill too much into this later in the presentation, but I will highlight it right now. As they have a landslide reporter where anyone with a Google, Facebook, or NCCS account can actually put points or polygons on the map and designate that area as a potential landslide. And then someone on the landslides team comes back later and actually goes to verify that point or polygon and make sure that it is a valid point. If that is true, then they will move it over to what's called the landslide viewer that has some more analysis, and it gives you links to the global landslide catalog. So at last count, they had collected about 13,000 landslide points that are readily available via the web for anyone who wants to download them. So this is our main landing page, but if we come back up to the top, when you first go up there, you'll see Start Mapping. If you click that, you will end up at our portal homepage. I'm already logged in, so it shows some of the features that we have. But I just want to kind of highlight this. and show you where it is, and we will come back to that in a few minutes. Let me refresh this page for Guacamole, and you'll notice here that it's getting me to log in, so I will do that. And every user, when they request Windows access, they will get access to 3 Windows VMs. The recommendation is that you don't really customize what you do too much on the Windows VMs. Try and keep it in your home directory or your no backup directory, so that if you have to, for whatever reason, go to another VM, you're not having to go scramble to find the data that you had on a particular node. So here is the ArcGIS desktop environment. So this is our catalog. So what I've done today for the brown bag is I've created a couple of things. So in this directory, you'll see that I have a file geodatabase, and 2 MXD files. One is for the polygons, and one is for Landsat. So you'll also notice here that there's an HDF Landsat file sitting in this directory. Before I go too far, I want to highlight where that file came from. So as I mentioned earlier, if you want to publish data from this environment and you don't want to try and copy it to the server, which can be problematic for a variety of reasons, you want to create a directory in what we call ArcShare Public. So if you're on a Windows VM, it'll be under ATT Project ArcShare Public. And you can see these are all of the various projects that are in here. If you do want to create a directory in here, please contact myself or Ryan Forbes, and we will give you some guidance on how to name that directory. So that's the ArcShare Public directory, but the other important thing to note is that we have mounts to other file systems. So you can see we have our home directories mounted, our no backup directories mounted, and as a note, these are identical to what you see in Linux because it is provisioned to the Windows environment. So what's key about that is that you can do things in Linux and then come over to Windows and you'll have access to that same data. So maybe you have a tool that only runs in Windows, then it's not like you have to copy it somewhere else. It's already co-located with the Linux home directories. So there are some different directories in here. So we have AT repo that has some data sets. But the one I really want to highlight is the centralized storage system, CSS. So that is available on the Windows nodes at the S drive. And you'll see here all of the various data sets that are added. One key one that I wanted to highlight was this Landsat directory. So to get that HDF file in that directory that I mentioned earlier, all I had to do was go in and I just randomly grabbed one. I went to LCA, went into a directory and grabbed one of the HDF files and its associated XML file. And it literally is drag and drop, right? Copy here, paste into my working directory under ArcShare Public, and we'll go back there real quick. And we can see here's our HDF file. Now, I added that HDF file prior to the meeting. I added that HDF file to an MXD, a map document, and you'll notice that it read the HDF file, and it also read all of the various bands separately. As a side note, there are ways that you can import this. You can use raster mapping to go ahead and set your color schemes and all of that. This was just a quick and dirty to show how possible, or what the possibility is. So you'll see here when it all comes in, I'll just pick a different one. It comes in grayscale. You can actually set the color ramp. We'll just do it for demonstration. And I just picked the standard elevation one, which probably isn't appropriate for this data. So I'll just pick another one here for this actual layer. And you can see we get the visualization applied. Now, So now I have this MXD file that has the Landsat data. That's all cool. I'll go back to this one that I symbolized earlier. So we can look at it here in ArcMap. But maybe I want to make a web map out of it, right? Maybe I want to show somebody something, or maybe I need to do some comparisons or whatever. I can actually go and go to the portal and publish it as a service, which I've already done in the interest of time. So you can see here I just have a Landsat image service. Before I open that in a web map, I just want to show you real quick. So the way that portal works is you have your own content and you can create subfolders based on whatever the particular project is, right? So this one actually just got loaded straight into the Landsat test directory, into my main directory, and I will go ahead and add it to a new web map. And it should zoom in, and shortly thereafter it should display my data. Now we have seen where we get a little bit of latency here, especially on these larger data sets. The key here is that it's pulling in about a 450 megabyte file in its raw format. So let me rephrase. What happens is that process right there is ArcGIS server goes to look at the directory and then pulls what it needs from the image to generate a lower resolution image for display across the web. As I zoom in, I get closer to the raw image itself, but it actually has to interpolate the image, generate a PNG, and send that PNG to my browser. So that's why you might see a little delay there. So there are tricks for speeding that up. But you can see I can zoom in, and it'll refresh the image for me and give me a little finer detail. So we'll let that process for a minute. And while that's working, I will go ahead and save this as a web map. So we'll call this Landsat web map. You always want to give it some tags so that it's easy to find later. This is my web map. And I'll go ahead and save that. Now that's back into my content. All right, so we can see that we've got our raster web map, or our Landsat web map ready to go with a little bit of data in there. But let's say I want to add some additional data, right? So if I go back over to my directory, you'll see that I have this demo polygons MXD file, and I actually have a feature class in this file geodatabase called demonstration polygons. That feature class is right here, right? So if I add some reference data, we'll go ahead and just pick, oops, sorry, I need to add a base map so that you can kind of get an idea where this particular, where these polygons are located. We'll just pick, I'll pick imagery. Now this imagery data is coming directly from Esri's servers, so I really don't have to do anything fancy to display that. I can change the projection or whatever. So these were just a couple of quick polygons that I wanted to show you for demonstration purposes. So I'm going to go ahead and remove this base map, and let's say I want to publish this to the server. So I'm going to do share as a service. I'm going to publish a service, and I will publish it to, this is my production server that I want to use. So I'm going to use the mapping server. Oops, sorry, I'll use my server one. My password just updated the other day, which is why that messed up. And I will call this demo polygons. I'm going to put it in a directory called brown bag. And then it asks me some information. You definitely want to fill in this information, so I'll just type in, this is the summary demo description type. All right, and then what you want to do, you want to get in the habit, whenever you're publishing to the ArcGIS servers, you always want to run analyze, because what it'll do is it'll actually look at this service, or the potential service, and it'll tell you if you have any errors. So for example, when I set up this data set, I picked World Eckert 4 as the projection, but if I look at my web map, or I'm sorry, my MXD document, you'll see it's WGS 1984. So that's the error it's throwing there. That can pretty much be ignored unless you're trying to get super precise with it, but for demonstration purposes, this should be fine. So I'm just going to go ahead and publish that out to the server. Give it a few seconds. Now while we're waiting on that, I want to go back to the ARC catalog instance here and show folks something that a lot of people don't know about. So you can work in your home directory, you can work in your no backup directory, you can work in the ArcShare public directory, but what we also have is we have some enterprise Postgres databases out there. When you go to publish something, if you have a specific need, like you want to have somebody be able to edit across the web, right? So somebody logs into your web application and they're digitizing polygons or something like that, you would likely need something like the Postgres databases, but I just want to kind of highlight real quick all of the data we actually have in here. You can add as reference on your maps. So for example, we have the Esri demonstration data. We have a whole set of data there. Again, not super high resolution, but it's free, so we went ahead and published it so that people would have access to it. What we also have here is this, there's the Highfield data, which is Homeland Security Infrastructure data set. So this is what's called Highfield Open. This is free data to all government agencies, and you can get it via web services, but a lot of times those web services are offline or they change. And it's hard to actually get the information. So what we did is we added it to our Postgres databases. And you can see it's 307 individual layers. So for example, if you want to know where RCRA sites are, for example, that information is in here. If you want to know where TV broadcast contours are, we have that. Right, so all of this information is readily available. I know that the NASA disasters team does reference Highfield data from time to time, but you can see there is just a plethora of data here, mining data. If you want to know where all the major sports venues are for whatever reason, you're doing some sort of analysis in that regard, that data is there as well. FAA information, that's there as well. Additionally, for the landslide data sets, the landslide reporter and viewer, we actually store their data here, right in this zone here. So anytime someone edits on the web, it actually writes the record straight into the Postgres databases, and we have controls in there to make sure that people don't go crazy and try and spam the databases from the web and stuff like that. All right. So let me go back to our service. So we can see that our service published successfully. So let's go back to our content and see if that's true. So here we can see I have my demo polygons. I'll go ahead and add them to a new map. And there they are. Now they look different because this projection on the web is almost always going to be the Web Mercator projection. So it's basically designed for better web display. It's what Google Maps uses, and Bing Maps, they all use that. So you'll notice that these polygons look different, but they are the exact same polygons. Let's talk about publishing content. So there are 3 ways that you can publish content. The first one is from ArcGIS desktop via either file geodatabase or a shapefile or something like that. Okay, we covered that. The second one is from the Postgres database. It basically works the same way, it's just the source of the data is pointed back at the Postgres database. The third way, and the above team uses this significantly, is published straight to the web. We can see here that we have a Fairbanks Hotspots GeoJSON file. I recently uploaded that file. I'll just show you what that data looks like. So this is a data set that came in GeoJSON format, and we were able to just directly on the web interface publish that data and get full functionality to symbolize based on features or whatever it is that our requirement is. So if somebody gave us a KML file, GeoJSON, and even a CSV, we can actually publish those directly through their web. So let's show how that works. So I go to my content, I click Add Item from my computer, and you can see I have some sample data sets. Let's load in the above study domain GeoJSON. Put a demo tag in here. And it's going to go ahead and take that GeoJSON, add it to the portal, and then spin up a web service to display that data. And depending on the size of the GeoJSON, it can take a little bit longer. It just depends on how big it is. Now the good thing is while this is working, I can go and do other things, and I can bounce back to it. But let's do this. In fact, while we're waiting for that, let's go make a new web map. So we have our Fairbanks hotspots, and let's go add search for layers. So what we can do is we can add all sorts of layers, whether it be from our content to the Esri Living Atlas. So there are likely thousands of services that are out there on the Esri Living Atlas that we can use to overlay with our existing data. But I'm just going to go back to the above study domain. So we're going to add that to our map, and we can see it kind of took over our map. So let's go fix that. And we'll change the symbol on it. We want no fill. We'll do an outline of, I think they use purple sometimes, and we'll make it a little bit bigger. And we can actually zoom to that layer. So, didn't require a GIS analyst, didn't require logging into Windows, nothing like that. Somebody literally gave us a file and we were able to upload that file directly to our server. So let's do another one real quick. In my directory, I have some bathymetry data. You'll notice it's a zip file. Now I don't know if this is a shapefile or a file geodatabase, but either way, if you're going to publish a shapefile or a file geodatabase, you have to zip it first because they have various pieces that go with it. And so by zipping it, you put it all together, and then the portal will decompress it and process it once you upload it. So I'm just going to call this demo. And you can see it detected that this was a shapefile. So again, it's going to spin up the service. We'll give it a few seconds. And while we're waiting for that, I'll just show you another way that you can add it. I don't have a URL ready, but you can actually add from the web. If it's data that someone else maintains, whether it be NOAA, USGS, maybe it's a reference data set to polygons of some sort, you can actually add it here. So you just put the URL reference. You can say it's an ArcGIS server service or a WMS. These are the various formats that the system will support. And then you just save it, and then you have a pointer back. So let's go back to our map, and let's see if we can add our glacier data. We can see here is the glacier demo data. So just like that, we were able to upload 2 different types of data sets directly to the portal without asking a GIS person for help. And that's really helpful, especially for people who don't have access to either the portal yet or the Windows environment. It's a lot easier to just get access to the portal and go publish data this way than it is to sometimes try to figure out how to use Guacamole, which we are here to help you do that. But the main point here is that there are multiple ways to get your data and visualize it in the platform. All right, so what I'm going to do is, this is a new web map, so I'm going to save this web map, and I'm going to call this demo web map. Okay. We'll just save it. All right, so now if I go back to my content, you'll see that I have a demo web map. That's great. But maybe I want to do something else with it. So let's go into the web map, and maybe I want to create a web app. So going back to that slide briefly, we had this where we were talking about the complexities of the various applications. Right now we're down here. We have a web map. There's really no measure tool, no widgets, nothing like that. We can actually use what they call configurable apps. I'll show you that, or we can do Web App Builder. So I think for today's demo, we're going to do Web App Builder, and we're going to push our luck a little bit. So let's see if it works. So I'll start here by using a template just to show you the various options. So let's say that you have 2 Landsat images that you want to compare pre and post event, we'll say. You could actually compare using a swipe or a spyglass, and you can see here they have the blue on one side and the red on another. You could actually kind of do a visualization where you move the swipe back and forth, and that's pretty helpful for seeing, post-damage assessment kind of activities. If you wanted to collect some data, they have some basic templates to do that. And you can see there are quite a few various pre-configured applications, and at every release, Esri adds new applications. All right, but we don't want to do that. We want a little bit more than what comes out of the box. So we are going to use the Web App Builder, and I'm going to call this my web app. And this is, all right. So the Web App Builder is going to spin up, and you can see it has me zoomed in here. So what I'll do is I will kind of zoom out a little bit so we get some reference. And you can see that's kind of hard to see there. All of our other data is there, for example. So if I look out, I should see my above domain is still there. So let's just do this. -2. Okay. So the first thing you want to do with your web app is you have to pick what kind of theme you want. And you can see how the display on the right-hand side changes. This is all code-free. I don't have to do any coding to get any of this stuff to work. This one is my favorite because it's a minimal design. And you can see we have various widgets that kind of fill in the bottom down here. We can change our symbologies. I like the darker display myself. We can say we want to use the current map view as our default extent. And I kind of like what I have here already. Maybe I change the layout a little bit. And what it's doing is it's kind of flipping over here in the top right. You'll notice the extra widgets are kind of moving a little bit. But there's really not a big change there. We can go to the various widgets. So we have the anchor bar, which is this piece at the bottom. And let's add another widget. We will add, let's call it a... So we're going to add a measurement down here at the bottom. And it'll give us, let's see, we'll do area in square miles as default and length in kilometers. All right. So then, now we have an additional widget here, a widget that's available for measurement. So we've got something down here in the anchor bar. But so what we have, just to recap here, we have the legend that shows us what's in the actual web map. As a side note, these titles don't look very good. So what we can actually do is when we go back to the web map, we can rename them in the web map, and they will display here properly. So just in the interest of time, I just wanted to kind of show the functionality. So this is the legend, but then we also have our layer list. So if we want to turn off specific layers by default, we can do that here. Okay. And we just talked about our measurement widget. Let's say I want to measure area in square miles. Like, what is the size of this thing? So it's a little less than 1 square mile. All right, so that's the anchor bar, but let's say I need to add some other widgets up here on the side, and you can see how that thing's in the way. We've got three options, right? So let's go to our first one. Now we can see that we have quite a few widgets available. Maybe we want, what's a good one? Maybe we want a print widget. That sounds good. And let's do something simple. That's easy. Maybe a swipe widget. And we'll do a horizontal bar for the swipe widget. Okay. So you can see those widgets were added over here. And you can configure which layers turn on and off in the widget, but just wanted to kind of show you the functionality. All right, so let's say we're done with that, right? So I'm going to go ahead and save my changes. If I come back to my content, Now I have my web app, and I can view my application. So what we did is we took some data that we loaded from the web, we added a base map to it, we published, we had the services, we created the web map with the colors and things that we wanted, and then we were able to add some widgets. And all I have to do now is change the permissions and set it to public access, and anyone who comes to our portal can have access to this. So going back to the Landsat image comparison, this is, you could do the before and after and just share this web app out, and anyone can look at it without any extra permission. Now, that sounds awesome, but there is one caveat. The one caveat is if you access data on CSS. So let me come back to CSS. If you have NGA access, do not share NGA data. I just want to put that caveat out there, right? Don't copy it out, don't share it. If you do, folks will find out and it won't be nice, so let's just not publish NGA data, but any of these other data sets are basically free and accessible for visualization and analysis.